Good morning, students. Okay, so before starting with the class, I don't know, but I'm telling it's for second year where we are going to go with electrochemistry revision. Fine. So I'm just announcing, I don't know whether first few students are there or not. Yeah, Dikshit. I think first few students are there. Okay. So it is second PU topic. Revision, that also revision, that is electrochemistry. First few students, no need to attend this class. Okay, no need to attend this class. You will be having chemistry class separately for first few students. Fine. That's where we have the electrochemistry, and all of you know already we have discussed with respect to some of the concept in electrochemistry, right? So that's what we have discussed in the last class. And if I am right, we were talking about concentration versus molar conductivity. Concentration versus molar conductivity, that is square root of C in the x-axis. So whenever we are talking about weak electrolytes, we used to get the graph like this. And whenever we are talking about strong electrolytes, we used to get the graphs like this. Alright? Only for strong electrolytes, they are going to connect with the y-axis. When it comes to weak electrolytes will not reach to the y-axis. Okay? So that's where we have the weak electrolytes, and that's where we have the strong electrolytes. Fine. So that's what we have discussed in the last class. And whatever is there, this is called as limiting molar conductivity. That is nothing but limiting molar conductivity. Now, all of us we know that. What do you mean by molar conductivity? Molar conductivity is nothing but conductivity of a 1 molar solution. Molar conductivity means what? So molar conductivity is nothing but conductivity of a 1 molar solution. Right? So that's where we have the molar conductivity. One thing is sure that in this case we are taking 1 mole of the substance. What do you mean by 1 molar? That is nothing but 1 mole of a solute dissolved in a particular volume, that is 1 liter. That is nothing but 1 liter. That's where we are going to get the 1 mole of a solution in any of the volume. But compulsion here is you should have the 1 mole of a solution. Now observe here carefully. When I am talking about molar conductivity, where it is equal to kappa divided by C. Kappa divided by C. Now, if I see molar conductivity, if I want to see the unit for the molar conductivity, we have seen that what is the unit for kappa? That is conductivity. What is the unit for kappa? That is for conductivity. That is Siemens per meter. Siemens per meter. Alright? So what is the unit for concentration? That's where the problem. If I am dealing with the solution, naturally I will go with the moles per liter, a common unit. We will go with the moles per liter. Or sometimes what they will do is Siemens per meter. Here it can be moles per decimeter cube. It can be moles per decimeter cube. All of you are understanding? While solving the problem, we will come across this particular units. So you should be knowing this one. Once again I will tell, molar conductivity is specific conductivity divided by concentration. Okay? So that's why we have the molar conductivity is nothing but conductivity of 1 mole solution or 1 molar solution. Now when I am talking about specific conductivity, unit will be Simon per meter. Unit will be Simon per meter. And for the concentration, since we are talking about molarity, since we are dealing with the molarity, the concentration will be number of moles per volume of the solution. Now comes, when I am talking about the volume, volume can be expressed in terms of liter, or it can be expressed in terms of meter cube, or whatever it is, right? So that's where we have the moles per liter. Now this moles per liter, so here since it is per meter, so I will write it as moles per dm cube, because liter can be expressed in dm cube. 1 liter is equal to 1 decimeter cube. 1 decimeter cube. Okay? So in turn, I can tell that molar conductivity is equal to 1000 into kappa divided by C. Whether I am clear? 1000 into kappa divided by C. Why I am getting 1000? Why I am getting 1000 multiplied by kappa? What is the reason? The reason is very simple. Lambda m is equal to Simon per meter. If I take this meter cube, decimeter cube upperward, it will become per decimeter cube and per meter cube. Got my point? Decimeter cube. So therefore, divided by, it will be moles. So here it will be moles. It will remain as it is. Now, deci means what? 10. So therefore, if I take this one, therefore it will become 1000. Therefore it will become 1000. All of you got my point? So therefore it will become 1000 kappa. While solving some of the problems, we will come across, they will be using this equation, where lambda m is equal to 1000 into kappa divided by C. That means whenever they are expressing in 1000, that means they are going with concentration with respect to moles per decimeter cube. They are not going with moles per liter. So that's how the conversion will happen. So 1 mole per liter. 1 mole per liter is nothing but 1000 mole per meter cube. Okay, 1 mole per liter. Please remember this one. 1 mole per liter is equal to 1000 mole per meter cube. So from where this 1000 came? That is due to this deci cube. That is due to deci. So 10 into 10 into 10. That's where we are going to get the 1000. That's how we can interconvert these things. So moles per liter we can convert it into moles per meter cube. Just multiplied by 1000. Okay, all of you have understood? So that's where while solving the problems we will use this type of equations. Any doubts? If you want to keep it in liter, no problem. But in many cases they will go with moles per meter cube instead of liter. They will go with moles per meter cube. Fine? So that is one thing. Then we were discussing about weak electrolytes. We were discussing about weak electrolytes, where it will follow y is equal to mx minus c. Where it will follow y is equal to mx minus c. So that means when I am talking about limiting molar conductivity, what do you mean by limiting molar conductivity? So this is where when this line is going to intersect at the y-axis, that is called as limiting molar conductivity, where the concentration is 0. Where the concentration will be 0. That's where lambda m is equal to lambda m naught minus a square root of c. Minus a square root of c. Now if you observe it carefully, y is equal to c minus mx. So that's where we have the equation. Y is equal to c minus mx. Where slope is nothing but Corlash constant. A is nothing but Corlash constant, that is nothing but m. M is nothing but slope. M is nothing but slope. So where we are going to get the negative slope value. Where we are going to get the negative slope value. That's what we can observe even by seeing the straight line. Now, depending on the type of salt, where NaCl, if you observe this one, it will give, or it can be dissociated into Na plus Cl minus, where each ion they are having one positive, one negative charge. So I will call it as 1-to-1 type. So if I take calcium chloride, this calcium chloride can be dissociated into calcium ion and 2 chloride ion, where one ion is having 2 positive charges and another ion is having 1 negative charge. So therefore 2 chloride ions will be required. So this can be a type of salt where we have 2-to-1 type of condition. Same way, if I take magnesium sulfate, so this magnesium sulfate can be dissociated as magnesium plus 2, sulfate minus 2. Now we have a condition where charges are same, plus 2, minus 2. Therefore, since it is 2 is there, therefore we will call it as 2 type of electrolytes. Okay, what I mean to tell here is, we can classify a given salt or given electrolyte based on the ions which they are forming. What is the charge of those ions? Based on that, we can have the different categories. For example, if I take aluminium chloride, naturally here it will be Al plus 3 and 3 chloride. So naturally it should be 3-to-1. So like that we have the different types of salt or different types of electrolytes depending on the number of ions they are going to form. All of you have understood? Okay. So that's where we have the Corlash law comes. Depending on this type of salt only, that's where we have the Corlash law comes into the picture. Now why Corlash law is there? Now Corlash law is majorly applicable to calculate the molar conductivity. Of a given electrolyte. It can be a strong electrolyte or it can be a weak electrolyte. And by using Corlash law, even we can calculate the limiting molar conductivity of a weak electrolyte. Because by graphical method, for weak electrolyte, we cannot calculate the limiting molar conductivity. That can be done only by using the Corlash law. All of you have understood? Say for example, if I take 1-to-1 type of salt or electrolytes, so in that case I have the NaCl. Now limiting molar conductivity. Okay, limiting molar conductivity of NaCl will be equals to which should be the Corlash law. According to Corlash law, what should be there? It should be equal to, anyone? Limiting molar conductivity of Na plus and limiting molar conductivity of Cl minus. Na plus and Cl minus. So what it tells here is molar conductivity or limiting molar conductivity of a 1-to-1 salt or any of the electrolyte if we take, it will be combination or individual contribution of each of those ions which will be produced by this particular electrolyte. All of you have understood? Fine. Any doubts? If for example, if I take calcium chloride as an electrolyte, okay? So I want to find out limiting molar conductivity for calcium chloride. So naturally it will be sum of limiting molar conductivity of calcium. It will be sum of limiting molar conductivity of calcium plus limiting molar conductivity of chloride. Now you should be careful. How many chloride? Calcium chloride can be dissociated into how many chloride? It will be dissociated into 2 chloride. Right? It will be dissociated into 2 chloride. Once again I will tell, I can see first PU students are there. It's not for first PU students. Shubhangi, I can see you. It's not for first PU students. It is for second PU students. Okay? So that's where we have the electrochemistry. It's a revision which is going on. So I am now talking about a very, very important concept, that is Corlash law. Okay? So now what is that Corlash law talks about? It tells that for a particular electrolyte, limiting molar conductivity of that electrolyte will be contributed by some of the limiting molar conductivity of individual ions which will be released by those electrolytes. So that's what I have taken the example. NaCl can be released into Na plus Cl minus. That's what we can observe, right? And when it comes to calcium chloride, it will be calcium plus 2 and 2 chloride ions. So that's where we have the Corlash law application, and that's where we have the Corlash law. That's where we have the Corlash law. All of you have understood? Any doubts in this regard? Fine. So shall I move to the next one? If you have any doubts, you can ask. If you have any doubts, you can ask. Any doubts? Okay, fine. So another important observation by Corlash is what you observe. If I take 1-to-1 electrolyte, I am not taking the example or not, I am not mixing the 1-to-1, 2-to-1 and all. Okay? So I am going with 1-to-1. So if I take limiting molar conductivity of NaCl, okay, and if I deduct that one from the limiting molar conductivity of KCl, I will get some value, right? I am going to get some value, and that will be equals to, limiting molar conductivity of KBr minus limiting molar conductivity of NaBr. So like that we can go on. What I mean to tell here is, whatever equation I have written, everywhere I have taken 1-to-1, 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 1-to-1. I cannot compare two different types of electrolytes. They are different electrolytes, done. No doubt NaCl is different, KCl is different, KBr is different, NaBr is different. NaBr is different, KCl is different, no doubt. Because they are producing different ions, but they are producing same type of ions. I am talking about number of charges on those ions. All of them, they belongs to 1-to-1 category. So Na plus Cl minus, K plus Cl minus. So therefore, in that way, if I take the limiting molar conductivity of NaCl, if I deduct limiting molar conductivity of KCl from this, I am going to have some value, and that will be equals to limiting molar conductivity of KBr, which will be deducted by limiting molar conductivity of sodium bromide. So why this is applicable? This is applicable because I am going with 1-to-1. That's why if you go back to the equation, I told A value will remain same. A value, Corlash constant, will remain same for similar type of electrolytes. That's what I told. For example, it can be X value. It is same for all the one-to-one electrolytes. It will be same for all the one-to-one electrolyte. Then A will be equal to what? Some value. It will be same for all 2-to-1 type of electrolytes. So like calcium chloride, magnesium chloride. So for all those things, it is applicable. So what I mean to tell here is, in previous equation, whatever we have discussed, that is limiting molar conductivity is equal to molar conductivity is equal to limiting molar conductivity minus A square root of C. I am talking about this particular value, A value. It will be same for different electrolytes, but they should be of same type. They should be of same type. So for example, I have a graph. This can be a graph for calcium chloride. This can be a graph for calcium chloride. If I want to plot it for sodium chloride, I am just giving the graph. It's a rough representation. So naturally it will be like this. For sodium chloride, what I can observe, since they are parallel, whatever slope we are going to get, it will be same. Slope values will for KCl straight line and NaCl straight line will be same. It cannot be different. But they can have the different limiting molar conductivity value, no doubt. Because we are dealing with Na plus Cl minus, Ka plus Cl minus. But if I take calcium chloride and NaCl, we will imagine this is for NaCl. Now for calcium chloride there can be some variation. For calcium chloride there will be variation. Naturally slope will change. It's all rough diagram to make you understand. Don't think that this is how we are going to get this straight line. Okay na? So what I mean to tell you is 2-to-1 type of salt, that is for calcium chloride, and 1-to-1 type of salt, that is for NaCl. Definitely slope value is going to get changed. Okay? So that's why we have the application of Correlash law. That's why we have the application of the Correlash law, and that's why his observation. That's why his observation. All of you have understood? Any doubts in this regard? Okay na? When it comes to weak electrolytes, another important equation, whatever we have discussed is, all of them, they are strong electrolytes. Now we are coming to weak electrolytes like acetic acid, which will be slightly dissociable in the water. It will not completely dissociable. Now when I am talking about weak electrolytes, we should know one of the equation which talks about degree of dissociation. That is alpha. In first PU, you people have studied in chemical equilibrium with regard to degree of dissociation, right? So that means I can tell that alpha is equal to limiting molar conductivity divided by limiting molar conductivity. Alpha is equal to limiting a molar conductivity divided by limiting molar conductivity. You should remember this particular equation, where you are going to apply this equation while solving some of the problems. If you want to see degree of dissociation, then you should calculate molar conductivity and you should know what is limiting molar conductivity. They might be given those values, then you should substitute those values, then you will get the degree of dissociation. Then you are going to get the degree of dissociation. All of you have understood? So that's where we have the another important equation. Okay, based on these things you can expect the questions. Based on these things, you can expect the questions, problems. Okay, na? All of you have understood? Now we have one of the phenomena which is called as electrolysis and electrolytes. Electrolytes. Now I can tell that electrolysis is a phenomena, but electrolytes, it is related to molecules, right? So what do you mean by electrolysis? Just now we have discussed. We have got a sodium chloride, which was a crystal structure, but when it is added to the water, now they will get dissociated. They will get dissociated as Na plus Cl minus. So that's what we can observe. If this will happen in the presence of electric current, if this lysis will happen in the presence of, this will happen automatically. If you take sodium chloride, if you add it to the water, no need to pass the electricity also. Immediately they will get dissociated because it's a strong electrolyte. Okay? Now when I am talking about this type of reaction where there will be dissociation of a molecule, if this happens, okay, board is blur. 1 minute. Now whether it is visible? Can you tell me whether it is visible? I think it's clear, Appa. I think it's clear, Vishwas. So that's where we have the lysis of this particular molecule, lysis of NaCl, which will be lysed as Na plus Cl minus. If this process happens in the presence of electric current, then it is called as electrolysis or dissociation of electrolytes in the presence of electric current is nothing but electrolysis. That's what I told. Electrolysis is a phenomena and electrolytes is nothing but solution or molecules which are in liquid state, which can be lysed when the electric current will pass through them. They are called as electrolytes. Okay, so they are called as electrolytes. Okay, again it is blur, sir. But here it's clear, because even ink is new one, pen is new one. Vishwas. Once again you can rejoin. Maybe network issue at your this one.
Put his quality to maximum.
Or you can put maximum this one. Quality.
Either 480 pixels or 720 pixels.
Fine. Can you increase it? Where you can find clear image? Or for all of you like this?
Vishwas is first year, right?
I don't know. Vishwas, you are first year or second year student? No, I'm just asking. I'm not asking because you are telling it is blur. I'm just asking whether you are first year or second year student. Okay, fine. Okay. So, if other people also observing it as a blur this one, let me know. Otherwise, Vishwas, here Mayank in Krishna is in the class and in his tab we can see the clear image. Not in the mobile. In another tab he is attending this class and I can see the clear image. That's why I am asking. Okay? So if everyone is having the same problem, let me know. Dikshit, I think it's for second year. Or if you want to attend, it's up to you. But it is for second year. Fine? Okay? Now that's where we have the electrolysis and electrolytes. Now I am coming to another very important concept, that is with related to Faraday's law. That is with related to Faraday's laws with respect to electrolysis. With respect to electrolysis. Therefore, to understand the Faraday's law, you should know what you mean by electrolysis and what you mean by electrolytes. Okay? So what you mean by electrolytes? These are the substances which are in liquid or molten state and which will be dissociated when electric current will pass through them. That's why we have the electrolytes. Now, what do you mean by electrolysis? It is the phenomena where there will be dissociation of electrolytes which takes place when electric current will pass through them. That's why we have the two terminologies which are related to each other. Okay? Now, when I am talking about electrodes, all of us we know that we will be having anode and on the other side we will be having the cathode. We will be having the anode and we will be having the cathode. Now, naturally towards the anode, anions will be entering into the picture and towards the cathode, cations will go into the picture. So that's where we have the cations and that's where we have the anions. Since we are dealing with the electrolytic cell, I am not talking about galvanic cell now. Please remember, I am talking about electrolytic cell where I will consider anode as positive and cathode as negative. Please remember, don't get confused. In the beginning of electrochemistry class only I told, anode will become negative, cathode will become positive with respect to galvanic cell. Okay? But now I am talking about electrolytic cell where anode will become positive and cathode will become negative. So therefore, anions will move towards the anode, cations will move towards the cathode. Because cathode is negatively charged, cations are positively charged. Anode is positively charged, anions are negatively charged. Okay? So now, based on this particular phenomena, there will be exchange of electrons will be taking place. Here, what we assume here is, since electrons, they are moving away from the anode. Since electrons, they are moving away from the anode. So therefore, we will consider anode as positive. And since electrons, they are moving towards the cathode. So therefore, cathode we will consider it as negative. All of you have understood why this will happen? That will happen because of the movement of the ions. When you pass the electric current, there will be lysis of electrolytes. So negatively charged ions, they will move towards the anode and positively charged ions, they will move towards the cathode. So slowly there will be movement of electrons will start because anions are electron rich species. Therefore they have the negative charge. Now they start donating the electrons. And cations, they are electron deficient species. Therefore they are positive charge. Now they are going to accept the electrons. So at respective electrodes, there will be deposition of these elements will take place. At respective electrode, there will be reactions which will be taking place. All of you have understood? So that's where Faraday's law talks about. Okay? Now first law tells that, it's very important. First law tells that the amount of these reactions at their respective electrodes. At anode part, what is that reaction? And at cathode part, what is that reaction? That will be decided by amount of electric current which has been supplied. First law talks about amount of electric current. It's very simple. Amount of electric current which is supplied. That's what the first law talks about. Here I have taken simply the example of NaCl. Okay, na? So to make you understand, that's all. Say for example, if I have supplied high amount of electricity, we can think that 10 sodium is getting deposited. 10 Na plus is getting converted into Na and they are getting deposited at the cathode. Same logic is applicable on the other side. There will be liberation of chlorine gas. There will be liberation of chlorine gas at this part. So now, what happening? Amount of this chlorine gas which is getting liberated, amount of this sodium metal which is getting deposited, it will be decided by amount of electric current which you have supplied. As we increase the electric current, this deposition and this liberation will also increase. As you decrease the electric current, this deposition and this liberation of gas is going to decrease. So that's where the amount of electric current is going to decide. That's what the first law talks about. All of you have understood? That is with regard to this case. Now, we will imagine that we have supplied the same amount. I am coming to the second law. I am supplying the same amount of electricity, no change in the amount of electricity, because I am supplying the electricity, it is under my control. So I am supplying a specific amount of electricity. First I took sodium chloride, then I have taken calcium chloride. Now I have taken calcium chloride. Simply I am taking the example. Okay. Now this calcium chloride, there will be deposition of calcium, and once again there will be liberation of chlorine gas, since I have taken the calcium chloride. Now I can observe that this condition and this condition, they are differs, not with respect to amount of electric current, because as I told, amount of electric current I am supplying, I will keep it constant, but I am changing the electrolytes. First time I took NaCl, second time I am taking calcium chloride. Now, second law tells that's where the second law comes. Now the amount of chlorine gas which is getting liberated and amount of calcium which is getting deposited, it will be differs. It will not be same as first case where NaCl we have taken. It will be different when it comes to calcium chloride. So what is the reason? The reason is, when I am talking about valency, sodium is having different valency, calcium is having different valency. That's where equivalent weight will come into the picture. That's where equivalent weight comes into the picture. Reactive part, it will be decided by the valency. So that's what the second law talks about. That's what the second law talks about. Okay? So it talks about chemical equivalent. It talks about the chemical equivalent. So what do you mean by chemical equivalent? That's where we are considering reactive part of the molecule. What do you mean by chemical equivalent? That is nothing but equivalent mass. Chemical equivalent is related to equivalent mass. That is nothing but atomic mass divided by reactive part. Atomic mass divided by reactive part, or in this case I can tell that atomic mass divided by number of electrons required to neutralize the atom or ions. To neutralize the ions. In this where we have the valency. Calcium is bivalent in nature, +2. That means one calcium ion requires 2 electrons to become calcium, a solid. Right? But if I take Na+, it requires just 1 electron to become sodium, which is a solid. That's where they differs in their chemical equivalent mass, or just you can mention it as equivalent mass, because atomic mass divided by number of electrons required to neutralize this particular metal ion, or naturally when I am telling number of electrons, actually it should be cations. It should be cations. All of you have understood? So first law talks about amount of electric current. Second law talks about equivalent mass of those cations which are involved in the reaction. Any doubts in this? So that's where we have the first law, Faraday's law of electrolysis. And okay. any doubts, please you can ask. You can expect questions from Corlash law, and you can expect problems on Corlash law, or you can expect questions on Faraday's law, and you can expect problems on this particular law. And it will be for 2 to 3 marks problems. Very, very important concepts in electrochemistry. If you have any doubts, you can ask. Okay? So with respect to Corlash law, it is applicable for calculation of limiting molar conductivity and molar conductivity. Okay? And but when it comes to Faraday's law, it is applicable for electrolysis, amount of electrolysis. That's where Faraday's law is applicable. Now we have an equation, you people might be knowing this one, that is Q is equal to IT. Okay, Q is nothing but amount of charge. Q is nothing but amount of charge. So what do you mean by I? Current. I means not me. What do you mean by I? I is current. And then into time. Current into time. Okay? So that's where we have the amount of charge, which will be deposited or passed, amount of charge. It will be equal to current into times, which will be equal to current into times. So what is the unit for current? It will be ampere. It will be ampere. What is the unit for time? It will be second. Very good. It will be second. If it is given in hours also, you should convert them into second. Okay. Now what is the unit for charge? It will be coulomb. Right? So that's where we have C is equal to A into S. That's where we have the important equation. That's where we have the important equation. All of you have understood? And that's where we have one of the value which is called as Faraday's constant. We have one of the value for Faraday's constant, that is F is equal to 96,500 coulomb. 96,000, round off, 96,500 coulomb. Now, further if I want to write, I will write it as coulombs per mole. Coulombs per mole. That means Faraday constant is nothing but amount of charge present in a 1 mole of ions or 1 mole of electron. That will be more appropriate. So amount of charge present in 1 mole of electrolytes. Right? Because 1 electron will have the charge of somewhere around 1.6 approximately 10 to the power of minus 19. Okay? So 1 mole, for 1 mole, this is for 1 electron, this many charge. How much for 1 mole of electron? 6.022 into 10 to the power of 23. So that will be the value. It is actually 96,480 or something it will come. We can take it as 96,500, round it off. Okay? So that's why we have another important term, Faraday's constant. So what is that Faraday's value? That is nothing but amount of charge carried by the 1 mole of electron, 1 mole of the ions. Any doubts in this regard? If you don't have any doubts, we will solve some of the problems. No doubts? Shall we solve some problems then? Okay? So you can write it down. First one, conductivity of conductivity of 0.2 molar, conductivity of 0.2 2 molar, 0.2 molar solution of KCl at 298 Kelvin. At 298 Kelvin is 0.248 Simon per second. Calculate its, it will be 2 marks question. Calculate its molar conductivity. Calculate its molar conductivity. Okay, so it will be a 2 marks question. Can anyone? So what they have given? Conductivity of a 0.2 molar solution of KCl at 298 Kelvin is 0.0248 Simon per second, per centimeter, sorry. Calculate this molar conductivity. It will be a 2 marks problem. It can be asked. So they have given the concentration, okay, and they have given the conductivity also. We have to calculate molar conductivity. Conductivity or specific conductivity they have given. Anyone got the answer? Okay, all of you can start solving. In the meantime, I will also start solving here. Answer. First, always you should write given data. According to given data, what they have given? Concentration. They have given the concentration, that is equal to 0.2 molar. Okay, so then they have given the conductivity. Then they have given the conductivity, that is nothing but copper. So concentration is nothing but C. Conductivity is equal to 0.0248 Simon per centimeter. Simon per centimeter. Now I have to write the appropriate equation. So which is that appropriate equation? That is molar conductivity is equal to, since it is Simon per centimeter, so therefore better we can go with the 1000 into kappa divided by C. 1000 into kappa divided by C. Now just substitute the values. Just substitute the values. Okay. Now if I substitute the values, now it will become 0.0248 Simon per centimeter multiplied by 1000 divided by concentration. How much they have given? 0.2 moles per, it will become dm cube. It will become dm cube. Now dm cube, d we have taken it as 1000, so we will mention it as meter cube. Still there is a problem. What is that problem? So one is in meter, one is in centimeter. So therefore we are better we can make it as 1000 centimeter cube. 1000 centimeter cube. So 0.0248 Simon per centimeter into 1000 divided by 0.2 moles divided by 1000 centimeter cube. 1000 centimeter cube. Right? So that's what we can write it, right? Because 1 meter is equal to 1000 centimeter. So therefore 1000 centimeter. Oh, sorry, 100 centimeter. Not 1000, 100. Fine. Can you solve it further? What will be final answer? Hundred centimeter is 1 meter, right? So therefore I have made it as 100 centimeter cube, since meter cube is there. Or you can make it as meter, anything is fine. Now I have got the answer as 124. Whether I am right? 124 Simon centimeter square per mole. Because centimeter cube. So it will become centimeter square. Therefore it will become centimeter square. Okay? Because it is in the denominator of the denominator. So therefore it will become centimeter square per mole. But 124, whether it is correct? So that's where we have got the answer. That's where we have got the answer. So what they will do is 1 mark for this equation and 1 mark for this answer. That's how 2 marks question will be distributed. So 1 mark will be given for your equation. By chance you have written a wrong unit or wrong answer, then 1 mark will not be given to you, but you are going to get the 1 marks because you have written the proper equation. So always write the proper equation. Always apply the proper equation. All of you have understood? Okay. So most of the time we have to go with 1000 into kappa divided by C only. That is because always this will be given in Simon per meter or Simon per centimeter. So no other option. We have to go with this equation only. We cannot directly use molar conductivity is equal to kappa divided by C. No, better to go for 1000 kappa divided by C.
So here, from meter cube we have converted it into centimeter cube. So 1 meter cube is equal to 10 power 6 centimeter.
Or I can have written 100 centimeter. Okay. Yes.
So it should be 124 into 10 power 6 Simon centimeter.
So it will become 10 to the power of 6. Yeah. So 10 to the power of 6 because it is 3 times, na? I have forgotten. Okay. All of you have understood? Now it's clear? If you have any doubt, you can ask. No need to hesitate. Okay, fine. So, anyway, next problem I will give, or I think it will take time. So, what we can do is, tomorrow we will continue with this particular solving the problems and all, because we are left over with batteries. And in batteries, many portions have been removed. Okay? So many portions have been removed from your batteries. That's where students used to feel bit difficult with respect to the batteries and all. How to remember those equations. But many of the concepts related to batteries they have removed. So therefore, tomorrow we'll solve some more problems in this concept, and then we'll briefly discuss about the batteries. Okay? So any doubts in today's concept? Have you got why we made it at 10 to the power of 6? Because 1 meter is equal to 100 centimeter. But we had meter cube. Therefore, due to that, it will become 10 to the power of 6. Mayank has told. So, therefore, this to 10 to the power of 6. It's correct only. I had written it wrong actually. Fine? Any doubts? Okay, so take care. Tomorrow we are going to continue with the class. If first PU students are there, once again I am telling, it's not for you people tomorrow also, it is for second year students. If you are interested, you can sit into the class, but if you have any other classes at this time, you should not bunk those classes. Okay? And chemistry class for first PU, it will be there afterwards. Thank you, Appa. Thank you.